Hey guys, this is Ms. Mo. We are doing the Test 1 review. These questions will be in the same order as your Test 1 review in your homeworks and will be the same order as our actual test. The numbers will be different. So, this number 1 starts off with dolls and there's 2 of them with blonde hair. But your test review in your homeworks might say 4 have blonde hair. So, the order of these problems should go the same, and the numbers will be different inside. Don't forget that if you do not do that online test review in your homeworks, then you will be blocked from taking your test 1, and then you will get a 0 on your test 1. So you have to do the review in order to take the test. Also, don't forget to make an appointment. If you don't make an appointment and you show up on a Friday and they're closed, then that's on you, and you get a 0. So please make sure and call the testing center and make an appointment so that you know for sure what day they are open and what day they are not open. Check the announcements for when the test will be open and the details of your cheat sheet and stuff like that. Check your announcements. Okay, so anyway, number 1, it says a set of dolls is in a packing crate. 2 have blonde hair, 3 have black hair, and 4 have red hair. If one doll is drawn at random from the crate, what is the probability that the doll's hair is not red? Okay, so to find probabilities, we basically do the part over the whole. Or another way to think of it is the piece over the total. I before E, except after C. Okay, so let's see. We're talking about how many total dolls? 2 plus a 3 plus a 4. That makes 9 on the bottom of my fraction. And then let's look how many dolls do not have red hair. Well, the red hairs are 4. So everybody with not the red hair are these blonde and these black-haired dolls. Those make up 2 plus 3, and that's 5. So our probability is 5 over 9, because the piece, or the part that we're talking about, is the part of the crate that has not red hair. So the dolls in the crate that don't have red hair are the blonde and the black hair dolls. And 2 plus 3 is 5, so I put that on top. Then on the bottom, you talk about the whole crate, or all the dolls, or the total dolls. And there's 9 total dolls. So the probability is 5 over 9. And then it says something about type an integer or simplified fraction. That means no decimal. If you put a decimal on your test, I'll give you partial credit, but not all of it. So just be aware. Okay, number 2, it says if one student is chosen from the school, what is the probability that the student is a junior? So we're going to do the part over the whole, or the piece over the total. So let's see here. We're talking about the juniors. How many juniors are there? 452. Okay. Then for the whole, that's another way of saying total. And to find the total, you add up everything that we're talking about. So we're going to add up all these numbers, and that's what's going to go on the bottom of our fraction. And you don't have to write it all long like this. You could just whip it in your calculator. On the day of the test, you do not need to turn in your work. So if you can do a problem like this all in your calculator, go for it. Or all in your brain, go for it. Okay, so I got 2,000 for the bottom, and the top is 252. But underneath our little box, it says simplify your answer. Type an integer or a fraction. So we need to simplify it. We need to make it smaller. Well, I bet we can divide this by 2, because 452 is even. Hi. So we get 226 on top, then divide the bottom by 2, and it's 1,000. And then we can still go, because that 226 is still even. It has a 6 on the back end. So 226 divided by 2 is 113. Over 1,000 divided by 2 is 500. And then I don't think we can reduce anymore, because 113, it's not even, so no even numbers can go into it. And if we try and divide by 3, decimal. 5, oh, wait. Decimal. 7, decimal. You get the point. So, we cannot reduce this anymore, so hey-oh, that's our probability. And the probability that I'll choose a junior out of these 2,000 people is 113 over 500. Or, if I wanted to divide that, to understand it a little better, it's 0.226. And if I want to change that to a percent, it makes 22.6%. So it's saying that we have a 22-ish% chance of grabbing a junior out of all these people. But you don't have to put the decimal, and you don't have to put the percent. I was just kind of explaining. Okay, let's look at number 3. Number 3 says if A and B are mutually exclusive, that means they have nothing to do with each other. Like above, the sophomores are sophomores and juniors are juniors. You can't have a kid that's a sophomore and a junior at the same time. So that's what mutually exclusive means. It means they happen separately. Okay, and it says if the probability of A is 0.3 and the probability of B is 0.1, what is A little hump B? Well, let's remember what that little hump is. That little hump means or. Or a fancy word for it is union. Yee. But what I need us to remember is anytime you see that, you add. Yeah. Okay, so it says one probability is 0.3, another is 0.1. What's the probability of both if there's that union in between? Well, that means what's the probability of this or that? Well, you just add them up. So 0.3 plus 0.1 equals 0.4. Huzzah! And you don't have to put the 0 in front if you don't want to. When you type it in, it should take it. Alright, next sucker. It says the following box contains the 9 letters shown. The letters are drawn one by one without replacement. That means once you take it out, it's gone. So, let's say this is your little bag of whatever letters, and you take a letter out. Once you take a letter out, you do not put it back in. It stays out. As in, the totals go down by 1. So that's what that without replacement means. It means the totals are going to go down by 1, or the possible letters will go down by 1. And you'll you'll understand what I mean in a second. Okay, so let's see here. It says we got 9 letters in a bag. We'll pretend that's a bag. And I take a letter out, but I don't put it back in. So the totals go down by 1, and our possible letters that we have go down by 1. And then it says, and the results are recorded in order. Find the probability of the outcome. Represent. Okay, let's see here. So represent, that's REPRESENT. Okay, I just drew blanks for each letter. Okay. First, let's count. How many R's are in this bag to choose from? 1 and 2. Okay, so there's 2 to choose from. But let's say I take a R out. R out. Let's say I take a R out and there's an R just sitting here on the outside. Yeah. How many R's are left inside? If I take one out, how many are left inside? Well, if there's 2 inside and one of them comes out, I only have 1 left. So that means the next spot where we have an R, right here, there's only 1 other R I could put in there. So, in this first blank, there's 2 total R's that could go in this spot. In the 4th blank, 1, 2, 3, 4, there's not 2 total R's that could go here anymore. There's just 1. And then let's see, is there represent anywhere else? Nope. Okay. Or is there R anywhere else? Nope. Okay. Let's look for, what's the next letter? E. How many E's are in this bag? 1, 2, 3. Okay, well that means the next time I come up on an E, there's not 3 anymore. There's just 2. So let's see where the next, I gotta write this out. R-E. Here's another E. And we said if you take out an E, there's not 3 left anymore. There's only 2. Okay, so let's put a 2 in your next E spot. What if I take away another E? Well, that means there's only 1 left. So there were 3 total. And let's say I throw an E on this second blank. That means there's only 2 left in there. Okay, so my next E blank, I only have 2 possibilities. Then my last E blank, I'll only have 1 possibility. Okay. Now let's look at, what's next? P. Let's see how many P's we got in here. Okay, P, P, P. Where are they at? Oh, there's just 1 P. Okay. Great. Okay. Now let's look at S. How many S's are there? 1. Okay. Now let's look at this N. How many N's are there? 1, 2. 1. And how many T's are there? 1. Okay, now you might be thinking, where's she going to get this 30,000 from this? Well, we're not finished. Okay, we need to multiply all these. Okay, so let's multiply these numbers. And I think I get about a 12 on top. Okay, but remember, probabilities are the part over the whole, or the piece of the total. And so far, we've just talked about the part. Like there are 2 R's in this whole thing. Then there are 3 E's in this whole thing. That's the only thing we've talked about. We haven't talked about the denominator, which is the total. Well, let's see here. Remember, I said that the totals go down by 1. Not only the possible letters go down by 1, that's what we already did. Like when this first 2R became 1R, we already did the possible letters going down by 1, but we haven't done the totals. So, for this first fraction, for the R, we're going to say 2 over, how many total letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means this first denominator is going to be a 9. So the probability that I could get an R out of that first grab is 2 out of 9, because there's 2 R's and there's 9 total. Then when we move to the E,